Hello and welcome back to Functions. First, I want to thank all the nice people that support this channel by liking and subscribing. It helps massively for me to make more videos for you to enjoy. As a thank you, the PDF version of all lessons are attached for you to download for free. Now in today's part 6, I want to talk about a method of breaking down rational functions called partial fraction decomposition. We begin with an example where we're given a rational function y is equal to 1 divided by x squared minus 3x plus 2. The goal would be to break this down into two simpler rational fractions. You might ask, what's the purpose of doing so? Actually, the goal here would be more applicable to calculus, especially if we were tasked with finding the integral of this monster. However, we won't cross the line to calculus. If you are interested, you can check out the other playlist. For now, let's just stick to learning how to decompose this into simpler rational functions. As you can see, on the bottom here, we have a quadratic function x squared minus 3x plus 2. And we would begin by first decomposing this, or in other words, factorizing it. If you're fluent with factorization, you can probably see here we would get x minus 2 multiplied by x minus 1. This is important because these two factors will be the new denominators of our simpler rational functions. This means our original rational function can be written as a divided by the first factor x minus 2, and then we add b divided by x minus 1. This means here we have two simpler rational functions. Now, all we need to do is find the values of a and b. Here, on the right-hand side, what we want to do is to combine the denominator, means making it into 1. So that means, for the first function, for the first rational component, we need to multiply both the upper part and the lower part by x minus 1. And for the second simpler rational function, we need to do the same, but however this time it will be x minus 2. What happens here now is we have a times the x minus 1 plus b multiplied by the x minus 2. The denominators are now combined and the same as the left-hand side. This means in order for the left-hand side and the right-hand side to be equal to each other, we need to solve the upper part, the numerators. Now, the best way to solve this would be using the zeros of our quadratic function, which we already know because we factorized it in the first step. From the first step, we immediately know that the zeros lie at x equals to 2 and x equals to 1. All we need to do now is to plug each of those zeros in here. So for the first case, when x is equal to 2, the b is going to vanish because it's going to be multiplied by 0. However, the a component will remain. What we get is going to be a multiplied by 2 minus 1, which is just 1, and equals to 1. So we have found the value of a. For the x equals to 1, we're going to do the same. However, this time the a is going to vanish, and what we're going to get is b multiplied by 1 minus 2, which is negative 1. So we can put a negative sign in front of b equated to 1. This means that the value of b is simply negative 1. So now we can take the values of a and b and put them into here. What we get then is this result right here. We had an original rational function with a quadratic denominator, and we managed to split this into two simpler rational functions with a linear denominator. This is not that difficult, so we will finish it here. In the next video, we're going to start a complete new topic using all of the knowledge that we have learned about functions so far. So I really hope to see you there and have a nice day. Bye!